My name is Jim Laskey. I'm the lead of the multi-language group in Lang Tools. And in that group, we are working on Nashorn, which is the JavaScript implementation that Oracle's sponsoring. We also have an implementation of Node.js, which we're calling Node.jar because it's implemented in Java. We're also working with Attila. Well, Attila is part of our group now, so MOP and Dynalink's all under our group now. So, and I imagine there'll be some other projects kick in underneath us. Alex's mic's not working; it's scratchy. I thought I'd like to talk about something in Nashorn, but then during the discussion of organizing, we said let's not talk about our languages. Let's talk about technical details or something like that. So. Brian asked me what was I doing, and I said, well, I'm just working on some JDI stuff. And he said, you're joking, right? And because JDI has been around for 10 years and pretty stable, and nobody's done much to it, and it's just sitting there. But we're in a situation where we have a programming language that's not really plugged into an IDE yet, and people want to debug it, especially the guys working on Node.jar. They're trying to trace through their code, and they have to go through all the extra frames that JavaScript is introducing, and it's a real nightmare. So I was trying to find somebody to actually work on debugging. I couldn't find anybody, and I said, okay, well, let's see how hard this actually is. It really wasn't that bad. So I thought I'd talk about it a little bit, and actually I'm going to give you a little gift when this is all over. Talk about it a little bit and try to get you over the hump and say, oh, if you have a programming language, it's not all about optimizing your code generation. That's the fun part, but you also have to support your language. And a lot of people have gone through and already created their own debugging, but there is a nice, solid debugger in there, debugging set in there. Obviously, this stuff that I'm talking about is all experimental and it's not, may never see the light of day, so we have to allow for that. So really, this, as I say, this is a discussion point about having maybe a multi-language development set that everybody can use for their language that runs on the platform. Everybody knows that the best way to do debugging is with print statements, and but that's that's a pain. So the debugging infrastructure is already there, and I'll give you a little introduction about what that's about. And the IDEs already understand JDI. Eclipse, NetBeans, IntelliJ, whatever your favorite IDE is, they already understand JDI. So why don't you take advantage of it? Okay. And for us, it was primarily driven because of Node.jar. We want to be able to remotely debug, your process sitting on a server from your client console. Okay, so the agenda is I'm just going to do a brief introduction of what this interface is all about. Just discuss about how you could set a framework up and what I've actually done as a framework. I'll give you some specific examples of what I did in Nashorn to implement it. I'll do a little demo to prove that I actually got it to work. And then maybe we'll talk a little bit about what a multi-language JDI looks like, and we'll follow it up with some Q&A. Okay, so these are just terms that are part of the specification. It's JPDA is the Java Platform Debugging Architecture. That's the overall blanket that covers it. The JDWP is the wire protocol. That's the side that sits on the client side, which interfaces with the VM, gathers all the information that needs to be passed over. And the JDI, which is the interesting thing for us, that's the side that's on the debugger. That's the part that actually does all of the descrambling and communication back and forth to the VM. All the information is available online. It hasn't changed in 10 years. It doesn't look like it's going to change in the immediate future, but so it's a well-defined API, and you don't need to really look in the fine details. And I'm basically trying to set it up here so you don't have to look at the fine details, but it's all there online. Okay, so what does the JDI do? Well, so the JDI sits on the debugger side and sets up the connection to the debuggy, the wire protocol on the opposite side. It can do it in one of several ways. It can set up a socket, or on the Windows platform, it actually can use share memory to pass the data back and forth. And it also does some of this launch and attachment management for you. Okay, so the protocols are pretty straightforward to use in the client, so it keeps it fairly simple. So then the next level things it does is it sends requests off to the debuggee. So for instance, you want to set a breakpoint. So they'll send a breakpoint creation request off to the debuggee, and then that will set it up. You make stepping requests, or you want to view values, view stacks, whatever, the threads, makes all those kinds of queries, and then response receives events coming back from the debuggee. Pretty straightforward stuff. Whoops. Okay, so I should talk about this diagram a little bit. Go back to this diagram. This diagram sort of clarifies the relationship between the two entities. You've got the debuggee in pink and the debugger in blue, and on the debuggee you have the wire protocol. On the debugger you have the JDI, and again it's the JDI we're concerned about here. So as we move forward here, and we talk about implementing a JDI level for your language, what I'm suggesting that you do here is to set up a proxy JDI. So it looks and behaves like a JDI, but what it's doing is actually proxying the standard Java JDI underneath it. Okay, so if you think about it, most of the time you just want to let things pass through. You know, so it's like if I want to find out what threads are running, okay, that you don't need to really look at that. You just want to pass that through. So you can just let it pass through the proxy. But if you want to view your object, the shape of your object or the shape of some of your values might be slightly different for your programming language. So you want to filter those, modify them, and pass them back through to the JDI. So we introduced this proxy JDI, which in turn calls the underlying Java JDI. So we have to create these wrappers around JDI objects that add our functionality on top of the existing JDI. Okay, so the first object I want to talk about is the virtual machine object. So this is the sort of the highest level object that you need to carry around all over the place. This is what you make your queries against. You ask the JVM what threads are running. You ask the JVM to give me a frame, what values are there. Set a breakpoint. You need the VM at the highest level. And in the construct that I've set up here, the VM object is also responsible for object factory as an object factory. So it creates images of objects that are being passed through from the JDI. And it's also responsible for interning these objects as well. So if you have, say, two variables that are pointing to the same object on the debuggy side, you want to make sure that they point to the same object on the debugger side so that you can say, oh, are these two objects equal? Oh, yes, I can do something because I know they're equal. That also prevents you from having multiple copies of classes. You don't have multiple copies of, let's say, of the string class or multiple copies of the double class on the opposite side. So it has a responsibility for interning these objects. The definition of it in the JDI, there's a set of objects that are defined in the JDI API. Virtual machine is one of them. So in this case, what we're going to do is create a subclass, an implementation of the virtual object, and it's a subclass of a mirror. And going to the next slide, I'll tell you what the mirror looks like. So a mirror is the root item, root object for all of the things that we're creating in our proxy JDI. It keeps track of all of the information that is necessary to access that object on the opposite side. So it needs to keep track of the VM is one thing, and the underlying object, the underlying JDI object, is the second thing. So when you create a constructor, which basically takes those two things, packages them up, and then we also have accessors to get them. So you'll find that all your requests will be going through the VM or going through the underlying object. You have them available to you in the mirror. So as an example, if you have request of some sort, it would require some arguments that need to be passed through, then the proxy would basically just pass the call straight through to the underlying object, passing the VM through to it. So all of your mirror functions would already be set up to do that, or all your proxy functions would be set up to do that. So as an example, StackFrame is an implementation of the JDI StackFrame, and the constructor would obviously take the VM and a StackFrame. The Java StackFrame is its constructor, and it would do something like in the case of set value. You basically want to pass the set value from your proxy through to the actual implementation in Java, and this is how you set everything up. There's also this facility that you need to set up called a wrapper, which takes the JDI, the Java JDI object and wrap it into your proxy JDI object. And that's primarily done by this wrapper class, which may in turn call the VM to actually construct the object or return the object for you. So it does all the management for you. Okay. So for instance, in this example, the overloaded wrap function takes a field, which is the Java field, Java equivalent field. You can think of it as almost like the reflection field, and wrap it up. Of course, it needs to do the null check. Once it's in place, then you can just access the field directly, access it as a JDI field or JDI field from that point on. Okay, so some specific examples in Nashorn. First of all, we should probably talk about some of the needs that some of the needs we've had in Nashorn. We want to make JavaScript objects look like first-class objects in Java. So in JavaScript, we have these containers that have maps, and the maps have properties listed in them. And if you want to get a value or set a value from that container, you have to find the property and apply some function against that property to get the value from the container or set the value in the container. So the actual Java implementation is not interesting to us at all because it's just going to cloud up our vision of what's going on in JavaScript. So we want to make that JavaScript container or JavaScript object look like a Java object, and we do that with some tricks in the proxy. So also we want the proxies properties. We want them to look like fields. We want to be able to get at the source code. There's some tricks there required. We're not always accessing source code from a file. Sometimes we have an eval, and the source code comes in from the eval. We need to make functions look like Java methods. And there's some internal types that we need to convert, like the date type. We want to make it look like a Java date equivalent. Probably the more interesting thing is that we wanted to be able to ignore the Java stuff. Like if you do a stack crawl, you don't want to see any of the Java stuff. You just want to see the JavaScript stuff. During this process, I was thinking, well, how would I actually use this debugger? So I introduced the notion of flavors. Primarily, the people would be using the JavaScript-only flavor, which is walking through my JavaScript code. I'm only looking at JavaScript objects. I don't really care about the Java world at all. For people who are using JavaScript as a layer on top of their Java, they want to be able to start execution at the JavaScript top level, but then be able to walk through some of their Java code. So that's the next flavor that you might want to have. And finally, maybe you just want to debug the Java code, but you want to look at the JavaScript objects as though they were first-level objects. Right? So in order to make Nashorn objects look like JavaScript objects, we need to create a subclass of object reference. Object reference is the JDI container for objects that have been ported over from the debuggee. So in order to determine whether it's a JavaScript object, we need to do some kind of class test to say, is this object a member of this class, of the script object class? If it is, then we need to treat it differently. So in the wrapper for object reference, so when we get an object reference come back from the JDI side, we need to wrap it, and then inside the wrapper there would be a test to say, is this a member of this class? If it is, then we got to wrap it differently. Okay, in this case we wrap it as a Nashorn object reference. So this is how we catch when we bring a JavaScript object over and want to catch it so that we treat it differently than just a regular object. The actual implementation for detecting the class type of an object is that we actually have to query the VM and to actually get that class and then put it in a class container and keep track of it so that if we actually want to compare to see if it's a member of that class, then we sort of have to do it lookup. And the way it's set up in this code is it does it lazily. So if you make a call and it hasn't found it before, it'll go off and get it. And then once it finds it, then it'll hang on to it so that the test is fairly quick. On the flip side of things don't really need to be that quick in the debugger because you have the human interaction thing going on there, and humans are so much slower than people. They tend to be. So the same sorts of things for fields. We want to be able to detect a property object, and when we detect a property object, then we convert it into a Nashorn property object on the JDI side. Okay, and again, it's a subclass of object reference. And the detection for that type is the same as we did for the script object. So once that's done, then we can do some fairly neat things. Like, so for instance, if we have a JavaScript object, we can get its map, and we do so by calling the get map function on that object. And what that does is uses a reflection, sort of use the reflection through the wire process to actually make that call, get the value, then return it, and you can work with it. So anything that you could have done in reflection, you could think of it you can actually do it on the debugger side. So if you have to call a function in order to get something, some value, then you can do that. Whereas, say, if you're doing straight Java, it would just pull it out of a table, right? So in our case, we have to call functions in order to make it work. Okay, so that's true of maps and properties. So once you have a property and you want to access it, then it's just a matter of invoking a method on the debugger side. And what this does is sort of does an RMI equivalent on the debuggy side, makes the actual call, and then you can actually get the value. So in this case, there's two invoke methods. One is to get the value of the key from the property, and then call the actual get method against the object on the debuggy side. And the same would be true for setting. Okay. Yes. Yeah, I know. It's been happening from the beginning, and we don't know what's the cause of it.
It could well be that the battery in the wireless mic needs to be changed.
Yeah.
So
Okay.
we have some extra batteries.
Pause.
They last about 4 hours.
Well, they changed one this morning.
Yeah, we changed one this morning, but it's.
I changed this morning as well. I changed it for the G2.
Oh, you did?
so
You did? Okay.
Yeah.
This may be a triumph.
All right. Well,
Maybe the battery's
they,
poor.
they don't last a full day.
You have to.
All right. Try now.
Okay, now is that better? It sounds pretty good.
It's at least temporarily better.
Okay, throw that one in. No,
No.
I hear it.
All right.
Okay.
Good try.
Okay, well,
Go back to your phone.
yeah. Yeah, this video might not show up on the website because it's too scratchy. Phew. Okay, so as I mentioned earlier, sometimes the source for Nashorn does not come from a file. If you're doing an eval, then you're basically taking a random string in order and evaluate the contents of that string. So we can't rely on the built-in mechanism in the JDI to actually get the file that the that the source starts from. So in this case, what we've done is just a little trick. We'd look at the file name and see if the file name ends with JS, which is a good indication that it was a JavaScript file, or it was an eval. Then we go off and what we do is we query against the JavaScript runtime on the other side to say, give me the source. And it knows where the source is. So again, you have to think in terms of it's not data sometimes is not sitting in a table somewhere. You might actually have to do some computation to get it. If you have a debugger that evaluates expressions, instead of having a parser sitting on the debugger side, you could actually just pass the string through to the evaluate on the debuggee side, get him to do the evaluation in the context that you want it to do the evaluation in, and get the result back. So you can do it with a series of calls. So you can think of this as basically a remote form of reflection. How do you make Nashorn functions look like Java methods? Well, in a debugger, it really doesn't really make that much difference. You need to be able to define the entry point into a method, and that's up to your naming convention or searching convention. You may have to add a function to do a lookup, a function in your runtime to do a lookup to find that function for you. But for the most part, you don't really have to worry about it, because the thing is that usually when you're debugging, it's line number correspondence that you're considering. Something I jumped over and don't even have a slide for is that when we generate code from Nashorn, we fill out the line number tables with the correspondence back to the source code. So we rely on the Java line number table. We also rely on the local variable tables as well to be able to find things in local variable tables. Another thing too is that in this example, at the bottom, sometimes Nashorn's frames don't just use local variables, they have to use a scope, because they're a continuation. You may have a nested function and there could be continuation. So we may have a scope. So sometimes values may come from the scope, or sometimes they may come from a local variable. So what we do is we have these two different property types. One is to access it from the scope, and the other is to access it from a local variable. And since they're both subclasses of property, the behavior seems to be somewhat the same. And probably the easiest part of it all is to get it to ignore everything else. All you have to do is there's the three event types that are sitting in the event request manager that you need to add filters to. It's basically the enter method request, exit method request, or the step request. And you create the request, and then you just add filters to it. So in this case, we're adding a class filter that says only take things that are in the script class. So that means it'll ignore everything else in the runtime. If you want to do it the other way, where you have a set of classes that you want it to ignore, for instance, I said we have these different flavors where one of the flavors may be that you want to be able to walk through Java code. You want it to ignore the JavaScript runtime support, so you just filter out those classes. So that's the other option you can do. Okay, so what I'm going to do is try to do a demo here, and I'm going to put my glasses on because I can't see too well here. And first of all, I'll just show you what the demo is. It's nothing complicated. I kept it short so that hopefully you can remember it long enough that when we're walking through the debugger, you can figure out what's going on here. So it's just to show you some different aspects of it. So the main body of the program here is this print at the bottom where I say print 100. It calls the first method, which takes an argument, which assigns a y, and then calls a second with two arguments. Second creates an object, assigns it to z, returns z, and then finally it comes back up. So hopefully you can keep track of that, and I'll try to list it out as we're going along. So now the debugger I'm using, I didn't have time to implement an IDE debugger interface, but so I'm just taking the JDB and calling it JSDB for JavaScript debugger, and just added a few tweaks to make this all work. So just ignore all the fluff up at the beginning. Those are all from startup scripts. So I've got it set up so that it launches the JavaScript right away, and then breaks in at the first operation. So this gives me the ability to actually stop at that point in the debugger. So as you can see, it's at the print statement, and I can actually do a list, and then I can actually list the code. So when I said list, it's gone off and found the source code in that line range and pulled it back and actually look at it. Okay, so I want it to stop. Oh, sorry, actually, I should say where first. Okay, so when I say where, it tells me it's in my my test.js class, and gives me the line number, line 11. Okay, and you can imagine what kind of bootstrap that must have happened in order to get to this point. So notice that all of the Java-y things are not there. They've all been filtered out. Okay. So then I say stop in test second. So I want it to stop in at the deepest level, and then we'll continue. And off it goes. And it stopped there. So if we look at the stack crawl now, okay, unfortunately the screen isn't wider because it would have been a lot easier to read, but you can see that there's our stack frames. And if there's any intermediate stack frames, they've been filtered out because they're not in the classes that I'm interested in. Okay, so I know exactly where I am, and I can look at the locals, and I've got 2 variables. They're currently instances. This is an optimization that we're working on that'll soon fade away, hopefully. So you can see x is an instance of integer. Okay, and if I want to print x, there's the value of x. Okay, that's all straightforward. If I do next instruction, okay, then I can see what do I want to do here. I want to dump z. Okay, so I can look at my object. So there's my rather complex implementation, Java implementation of my object, but it looks like a fairly simple object. It looks somewhat like what the JavaScript would expect. And I guess that would be it. Okay, I can step next. Okay, and next. And if I do a where, you can see that it's popped the frame up. And you can do the up and down business that you would normally do from one of these debuggers. Okay? So, pardon? Yeah, that's uninteresting. I'll go back if we have time, if you want. Okay. So what does a multi-language JDI mean? Well, I think the thing is that I don't know if it really requires that much if you want to look at it in these terms. It was pretty straightforward to do. As I say, I had this all working in about 3 days from a particular starting point. I'll come back to where that starting point is. But I think that, first of all, I have to say is there a demand for it? Are you so crazy about your language that and optimization and compiling that you don't really care about debugging for the end user? So that's the first question I guess I want to ask. Second thing is that I did this from a boilerplate that I kind of stole that's been through a couple of generations. This boilerplate was this proxy already set up, and all I had to do was fill in the blanks. And that's my gift to you guys. Anybody who sends me a request, I'll actually send you the boilerplate, so that all you have to do is fill in the blanks. So.
Put it on GitHub. What's your email address?
Yeah, well, I'll give you that in a second here. I was actually trying to post it on the conference site, but there's Oracle has this restriction about posting zip files, and the tar file was too large to get up through the wiki. So maybe we can get somebody to wedge it in after. But anyway, there's not enough of you here to swamp me, so I think if you just send me an email, it should be fine. The other thing that I wanted to consider was the notion of, we're talking about having a MOP implementation to allow intercommunication between languages, right? Currently we're talking about Dynalink, and we're using Dynalink in Nashorn. So maybe it's time to think about setting up an equivalent sort of thing for JDI as well, where in your language you set up a set of somethings, and then we have a standard JDI which goes off and calls those somethings, and you basically have it defined in your language, and you don't have to take care of do anything else. So that's worth considering, right? Whether it's on the JDI side or on the wire side, it'd be obviously a lot easier to implement it on the JDI side, but you know, if the community bears down on it, it could also be part of the wire protocol as well. Okay. And I only had one more comment. This came from yesterday, where we're talking about debugging method handles. We really need to have the ability to debug method handles and lambdas. So as I say, there's my email address. Okay, so you can just send me an email and I'll just fire it off to you. So it's about, pardon? Oh, okay, good, sure. So once you get the boilerplate downloaded, you just change all the lowercase x, y, z, z, x, y, y, x, lowercase to your thing, and then the uppercase version to your thing, and then rename the files. Once you've done that, you should be able to build and run the JDB and just do straight Java debugging, and then you start adding your filters and your add-ons, and it should just work for you. As far as plugging into IDEs, I didn't put the IntelliJ one down here, sorry, the Eclipse one down here, but there's the plugin information is readily available. It's probably the easiest to do NetBeans, but obviously you all have your favorite IDEs, so it just raises the level too, that you have to do it ×3 if you want to support multiple IDEs. That's my contact, so you already got that. And time for Q&A.